Welcome to 13.6 Algebra 2 video lesson, and the concept here is the tangent function, and there's 5 boxes for us to talk about. So I'm going to talk about box number 1. So I just want you to remember that the sine curve and the cosine curve both come from the unit circle. And since this topic is called the tangent function, I'm going to tell you where the tangent function comes from also. The tangent function also comes from the unit circle, but it's a little bit harder to see, so I want to make sure that we remember a few things. The sine curve is the culmination of all of the y values around the unit circle, and then the ones, of course, that aren't on the unit circle that we don't actually have a nice exact value for us. But the ones that we do, we simply plot them and we get this beautiful curve. Same thing for the cosine curve. We look at all the x values, and we plot those, and we get the cosine curve. So you should be really comfortable with both the sine curve and the cosine curve up to this point, okay? Now remember a few things here. From geometry, we know that the sine is the opposite over the adjacent, the cosine is the adjacent over the hypotenuse, the sine is the opposite over the hypotenuse, and the cosine is the adjacent over the hypotenuse. And then, of course, I was trying to get you all to remember how things work when we're talking about triangles that are on the unit circle, and we just make the hypotenuse 1. So we've already learned that the cosine is worth x and that the sine is worth y. Now you may recall back from geometry that the tangent was just the opposite over the adjacent. Well, if we recall, or if we look at this triangle in terms of the unit circle, if this is my angle theta over here, the opposite side is the y side and the adjacent side is the x side. So it must be true that the tangent is just the ratio of the y value to the x value. So if we look around at all the unit circle values that we have here, remember that this is the x value, this is the y value. 30 degrees is the same thing as pi over 6. So if I were to draw a triangle here, okay, this would be my angle theta. The x coordinate would be rad 3 divided by 2. The y coordinate would be 1/2, so therefore the cosine is worth rad 3 over 2, and the sine of 30 degrees, or pi over 6, is 1/2, and of course this is 1. But now if I want to talk about the tangent, I need to take the ratio of the y value to the x value, so it would be 1/2 divided by rad 3 over 2. That's what you're going to see me do in these examples right down here. Okay, I know this is a long box, but all you have to do is sort of follow along and understand where these things are coming from, okay? So let's do a quick little example here. Let me erase this, and I'm going to show you how to do these. These are the important ones, the ones down here in green. So let's find the example for the tangent of 0. So here's 0 degrees, okay? Remember, we want the y value over the x value. So the y value is 0, the x value is 1, so therefore the tangent of 0 must be 0. If I look at 30 degrees, I want the y value to the x value. So that's going to be 1/2 divided by rad 3 over 2. So that's going to be 1 over radical 3, but we don't leave it like this, everybody. We rationalize to rad 3 over 3. So therefore, the exact value for the tangent of 30 degrees is equal to rad 3 over 3. How about 45 degrees? Again, we want the y value to the x value, the y value to the x value. So it's going to be rad 2 over 2 divided by rad 2 over 2. Well, look at that. If I have the same thing divided by each other, I just get a value of 1. Let's look at 60 degrees. Again, we want the y value, which is rad 3 over 2, divided by the x value, which is 1/2. Okay, so I'm getting radical 3. So the tangent of 60 degrees is equal to radical 3. What about 90 degrees, though? 90 degrees is a special one because remember, again, we want the y to the x. So if I take 1 divided by 0, this is going to be undefined. Okay, this is going to play an important role in the graph later on in the lesson. So there are certain points around the unit circle where the tangent is not going to be defined, and those points are going to be wherever we get a 0 in our denominator or wherever the x value is worth 0. Okay, last one, the tangent of negative 30. The tangent of negative 30, if I swung down this way, right, negative direction, again, it would be negative 1/2 divided by rad 3 over 2. Again, it's the y value to the x value. So notice I get negative 1 over rad 3, which is negative rad 3 over 3. So again, nothing special. All we're doing is looking at ratios all around the unit circle. And the one that we're focusing on is the tangent, and that ratio is going to be the y to the x. Okay, I'm going to show you how to do these examples here in box number 2. Let's find the exact value for the tangent of 2 pi over 3. So here's how I want you to think about it, all right? First, think about a unit circle, all right? And think about where 2 pi over 3 is. 2 pi over 3 is the equivalent of 120 degrees. So if you're not quite familiar with graphing where the radians are, you can always convert it to degrees. So 120 degrees is going to look like this. Okay, there's 120 degrees. That means that in my triangle, my reference triangle, this right here is going to be worth 60 degrees. Okay, that's 60, that's my 30. Let me make this a little bit bigger for you guys so you can see. Okay, so now if I think about a point that's right over here, an X and a Y, there's an X and a Y. This is 30, 60, 90. So I know that this is going to be 1/2 and this is going to be rad 3 over 2. But because I am in quadrant number 2, we have to remember that this one is going to be negative. The X value has to be negative because think about getting to that point. I go left and then I go up. So that's going to be negative. So the coordinate over here corresponds to negative 1/2 comma rad 3 over 2. Now the tangent is the Y to the X. So that's going to be rad 3 over 2 divided by negative 1/2. The 2's cancel, which give me a negative rad 3. So the tangent of 2 pi over 3 or 120 degrees is equal to radical 3. Okay, let's do number 2, the tangent of negative pi over 4. So again, I want you to think about negative pi over 4 is the same thing as negative 45 degrees. So I'm going to swing down this way. So if I think about the triangle that I would draw, a reference triangle, this would be rad 2 over 2, and this would be rad 2 over 2. Now, because I'm in quadrant number 4, this is going to be, the X value is positive, but the Y is negative. And again, that just comes from a 45, 45, 90 special right triangle because the hypotenuse is 1. So the tangent is if I think about the point over here, this is an X and a Y. So this is rad 2 divided by 2 and a negative rad 2 divided by 2. And the tangent is going to be the Y value to the X value. So I get negative rad 2 over 2 divided by rad 2 over 2, which is just negative 1. So if you actually plugged in your calculator the tangent of negative 45 degrees or the tangent of negative pi over 4, depending what mode you're in, you would get a value of negative 1. Okay? All right, and then the last one, let's do negative 5 pi over 6. Okay, so negative 5 pi over 6. So if you're not sure where that is, think about it. Here's the picture. Okay, 5 pi over 6 is a positive 150 degrees. So negative 5 pi over 6 is going to be right over there. Okay, if I drop it. So when I draw it. So here we go. So let's think about how we would draw it. So I would have, this is be negative 150 degrees. So that means that this is going to be a 30-degree reference triangle. All right. So across from 30 is 1/2. Across from the 60 is the rad 3 over 2. And of course, the hypotenuse is 1. Now, both of these are negative because I'm in quadrant number 3. So therefore, I'm going to take the Y value to the X value. So remember, this is negative rad 3 over 2, comma negative 1/2. So the Y value is negative 1/2 divided by negative rad 3 over 2. 2's cancel, and I get positive 1 over rad 3, and we rationalize to rad 3 over 3. So in my calculator, if I were to plug in the tangent of negative 5 pi over 6 radians, I would get a radical 3 over 3. Okay. Okay, box number 3, a U try. Find the exact value for the tangent of 7 pi over 6. Try it for yourself. Draw the picture, draw the reference triangle, and figure out the tangent of 7 pi over 6. Okay, hopefully you got the right answer of radical 3 divided by 3, because this is the exact same picture as the picture that we did in the previous example, except I just gave you a different degree, right? So of 7 pi over 6, it's the same thing as 210. So I draw the triangle in quadrant number 3. I have a 30-degree reference angle. That means that this has to be 60 degrees. So this is going to be rad 3 over 2, 1/2. Both are negative. Take the quotient of the Y and the X terms, and you get radical 3 divided by 3. Okay, here's box number 4. It's a big box, so let's make sure we understand what's going on here. So on the left-hand side, I have the unit circle again. On the right-hand side, I actually have the picture of the tangent function f of x equals tangent of x. It looks, some people told me it looks like bacon strips. I don't know. If that's what you see, then that's what you see. But it's a funky looking graph, okay? I do think it's important that you understand where it comes from. So again, all we're doing is we're taking the quotient of the x value, or sorry, of the y value to the x value all the way around the circle, and it produces this graph here. So as an example, the tangent of 0 is 0, the tangent of pi over 4 is 1, and so on and so forth as we go over around the unit circle. I do want you to notice that this graph is I'm going to break this graph up for you into quadrants, okay? So everything that happens from 0 to pi over 2, so everything that happens here, that's in quadrant number 1. Everything that happens here, this is in quadrant number 2. Everything that happens here is in quadrant number 3. And then quadrant 4 is off the graph. But you'll notice that if I were to actually go backwards to negative pi over 2, that would put me back in quadrant number 4. So everything that's happening here is actually in quadrant number 4, and it would actually repeat itself over here. So very interesting graph. The thing that we want to take to note is that the important parts of this graph happen right here, basically from here to here, because everything happens on this interval, which you'll notice is pi units long, from negative pi over 2 all the way to positive pi over 2. So therefore, the period for the tangent function is worth pi. That's the very first part that we want to make sure we understand, okay? And at pi over 2, and at these intervals of pi over 2, like 1 pi over 2, 3 pi over 2, what we're getting are these vertical asymptotes. And the reason is because at that point, those are the points that are undefined. So the domain is going to be all real numbers x, such that x is not a multiple of pi over 2, or I should say an odd multiple of pi over 2. That's a weird domain, and many students have a hard time understanding why that is, but at pi over 2, at 1 pi over 2, you get an undefined x value, because it's not defined there. At 3 pi over 2, you get an undefined x value, and all the way around the circle, keep going and going forever. So for any odd multiple of pi over 2, it's not allowed in the domain for the tangent function. So really, the two pieces of information that we want to make sure we understand are that the period is worth pi, and that at these intervals of odd intervals of pi over 2, we get a vertical asymptote, okay? I'm going to show you how to graph, and the next one of these are the basics for the tangent function. Okay, box number 5, our last box. I'm going to show you how to sketch the graph of y equals the tangent of 2 theta on one complete cycle. So let's begin with just a regular old tangent picture again. So for one period for a tangent picture, or a tangent function rather, we know that one asymptote will be at negative pi over 2 and the other asymptote will be at pi over 2. So if I were to just do a quick little sketch here for you, so I'll go 2 places. I'll call that pi over 2, and then I know I'm going to have an asymptote here, and this is going to be 0, so that has to be pi over 4, and this would be negative pi over 4, and then a negative pi over 2, and I know I would have an asymptote here. So the normal tangent function looks like this, and then at pi over 4, I'm up at 1, and negative pi over 4, negative 1. So here we go. So I'm going to give you like a quick little sketch of the normal tangent function, okay, and then compare that to the thing that we have. So this is all you have to do. So notice that this distance right here is a period. The period is equal to pi. If I go all the way from negative pi over 2 all the way to positive pi over 2, I've got a distance of pi. We learned all this in the last box, okay? Now, what we have here, since the period is equal to pi, and I have a 2 in between there, so I'll do everything in blue for you, or in green for this new graph, I'm going to get the period of this new function by taking the original one, which is pi, and dividing it by that number in between the trig function and my angle, so pi over 2. So now I know that the period for the function that I want is going to be pi over 2. And the way that we find the asymptotes is we compare it to what we already know about the tangent function, and the asymptotes being between negative pi over 2 and pi over 2. So I'm going to say, okay, I know this. I know negative pi over 2 has to be less than, I don't have theta anymore, I have 2 theta. So 2 theta, which is now less than pi over 2. So notice I have inserted whatever is here into this inequality, and this is going to tell me where my asymptotes belong. So if I divide everything by 2, I get negative pi over 4, is less than theta, which is less than positive pi over 4. All I did was just divide pi over 2 by 2. So now I know that the asymptotes are going to be shifted from here between negative pi over 4 and a positive pi over 4. So this is going to take care of one period now, and notice that that period has a length of pi over 2. So all I have to do is, this is my center line, a quarter of the way up I'll be up at 1, and a quarter of the way I'll be down at 1. So this is what this graph would look like, and I'd have asymptote and an asymptote. So you'll notice that 2 has shrunk the graph sort of horizontally. And I do have a picture of what it looks like for you in Desmos to get a sense of it. You can kind of see that here's pi over 4, my scale, and all that we're responsible for is drawing this one sort of period right in the center of the graph, okay? We will practice more of these in class, but I want you to be exposed to it now.